consider a problem like this. The sum of the series from k equals 1 to infinity of 1 over k plus 1 times k plus 2. We'd like to know if what the sum is, and we're going to consider this because there's some special features of this. Now this rule, 1 over k plus 1 plus k plus 2, is something that we can evaluate using partial fractions. And the idea behind partial fractions is that this complex fraction, if you will, must have come from, or could have come from, the sum of two fractions. One of them with one of the factors as a denominator, and the other fraction has the other factor as a denominator. And we do know that if we had to add these together, we would get a common denominator. And to get a common denominator with the first fraction, we would multiply the top and bottom by k plus 2, or my numerator would be a times k plus 2. And with the same idea in the second fraction, I would multiply b times k plus 1 in the numerator. Since this is just the numerator that would have come from getting a common denominator, I know that their sum must equal 1, the numerator of the original fraction. So by distribution we can see that AK plus 2A plus BK plus B must equal 1. And that means that these things combine in such a way that we're left with the value just 1. Now k is a variable in this circumstances. And notice that my right hand side, or the numerator, doesn't have any k's in it, which means that the sum of a plus b must equal 0, because there's no k's left at all. And that also means that 2a and b are the values that form the constant, or 2a plus b must equal 1. Well, now this is a very nice systems of equations. I'll solve this by elimination. So this means that negative a equals negative 1, or a must equal 1, which means that b must equal negative 1. So a is 1, and b is negative 1, which means we can look at this series in a new light now. It's no different than 1 over k plus 1 plus negative 1 over k plus 2. Now let's just look at what happens with our terms. When k is 1, our first term is 1/2 minus 1/3. And our second term, when k is 2, is 1/3 minus 1/4. And we're going to see this pattern throughout all the terms, where things keep subtracting out. Right? And the kth term, if we kept going, this is going to go to something like this. Not something like this, it'll go to this. Right? And it's always these terms that are canceling out every time in terms of this series. Which means that our series, what's left of it, once we combine everything, is the very first term, which never got subtracted out, 1/2, and 1 over k plus 2. Now we can ask, seeing this, we can ask a question. What is the limit of this as k goes to infinity? Because everything else cancels out. Well, the limit of this constant is just 1/2. As k goes to infinity, in our second term, the denominator is getting huge. And 1 over a huge number is, the limit of that is 0. Another way to think about it is that the degree of the denominator is larger than the degree of the numerator, so it's growing faster. So this is going to 0. So our sum will be 1/2. Now this is a special kind of series called a telescoping series. Telescoping series and a geometric series, when we recognize them, we can evaluate their sums quickly and have a way of dealing with whether they converge or not. If a series is not telescoping or geometric, now we're going to have some trouble dealing with both the sum and trying even to decide if it converges or diverges, which is why we're going to learn a ton of tests, 7 or 8 of them, to determine convergence or divergence.